Hi, in this video, we're going to be introducing the idea of how two quantitative variables relate to each other. And I have just a little, a little lab or, just to show you how we can collect some data and look at the relationship between variables. And the variables that I wanted to work with is going to be weight of books. We're going to look at, here's your textbook, sort of how many pages are in your textbook. And so we can go to the back of the book and see how many pages are in the textbook. And then I have my kitchen scale so I can weigh the textbook. And I chose a few books here to play with for this analysis. Podium. Woo, 10 books. All right, so I use these 10 books and I'm going to use these 10 books. I'm going to look at this book here. This is the smallest book on top, so it's easiest to handle. This book has 198 pages. So we are going to consider the number of pages, and just as a helpful unit, I'm going to work with hundreds of pages, and I could work with pages, but when we go to interpret stuff in terms of ounces, looking at the hundreds of pages might make it easier to understand that, what the model is predicting about the weight of 100 pages. So it seems more like it will be in ounces than sort of milligrams or something like that. And I have a better understanding in my own mind of how things relate around ounces. So I wanted to at least tap into that. So I'm going to use hundreds of pages and the weight in ounces. All right, so let me get this going. We said this was 198 pages, so 1.98 hundreds of pages. And I'll weigh the book. And the book weighs 18.00 ounces. So right on the money with that. Okay, and we could go ahead and we can choose another book here. This is 661 pages, so 6.61 pages. And we get 46.65 ounces. All right, so I'm going to follow through with all 10 of these and pause while I do that so you don't have to wait. And I'll meet you back in just a moment. Hi, so here's sharing my screen. I got all 10 books in, and I actually sorted them from the smallest to the largest. So from the little white book to the big green, your textbook. And over here, I plotted a scatter plot. So we can kind of talk about what a scatter plot is. So we see here, this first point is 1.98, so it's really close to 2. That's the, so we're plotting x comma y coordinates on a Cartesian plane. That's what you might have heard it as in algebra class, right? And then the weight was 18. So this point represents the x of 1.98, the horizontal axis, 1.98, we're going to call that x. The y-axis will call, the vertical axis will call y. And this one has 18, so it's over here. Now your big book was 855 pages. So right around there, right? And then we go straight up and we go to the weight of 66 pages. Okay, so what we want to do is we want to draw the best line we can on this graph. And what we're talking about in this chapter is really all about what is that best line? How can we use that best line? When is that best line best for, and when is it not so good for modeling this relationship between the X and the Y variable, in our case, pages and ounces of our books. Okay, so I have another, I will pull that up. So this software system is just a helpful little system that I use. We're not going to use this in the class, but for the purpose of the video, it actually showed up better than some of the other ones I tried. So you can kind of ignore the technical details and just try to soak in the relationship between the weight of the books and the weight of the book, the number of pages and the weight of the books. Okay, so here is what we call a fitted line plot. It has all of the points that we had on the previous scatter plot, but this time it has a line. So we have a line here, and this is the line that best fits the points. This is the straight line that best fits the 10 points on our scatter plot, right? And so what we see is that sometimes the points lie pretty close to the line, like this guy right here. And sometimes they don't really lie so close that there's a distance between the point and the line. So I just want to begin to understand and talk about what this value is, how we relate these points to this line. Okay, so we already know that this point here is at 18 because the book, which is 1.98 hundreds of pages, weighs 18 ounces. Okay, but what if we went straight up from 1.98 to that line and we went over? That's how we would use the line to predict what the line says a book will weigh at 1.98 is going to be like that. So suppose we had a book that was 600 pages. Okay, so the X value would be 6. The model predicts that the book would weigh, and I go straight up here to the line and then bring it over. So maybe just about 40 ounces. So the model predicts that a 600-page book will weigh about 40 ounces. Okay. Sometimes, in this case, we have, for this particular data point, we know that it is, and I'm going to look back at the data here. It's just taking out my ruler. So it's between 6 and 7, but so it's one of these two, and it's the bigger one. So this one here, I'm sorry, the smaller one, I was looking at this guy. So 6.49, and the actual weight of the book is 36.05, right? So if I cut straight across, I would get to 36.05. But I know that the model is predicting that the actual weight of the book would be up here. Okay. So let's go back to the whiteboard. I want to write the equation that we have. So this line, there's an equation of this line. I want to put that up on the whiteboard and play around with predicting weights of books and also getting some measure of how well the line does to predict or estimate the weight of the book. Okay, so I just brought the regression equation, the best fit line. These are all words we'll use, right, for that line. over here, where we have weight in ounces, is equal to 1.1. I rounded it to 1 decimal place, plus 6.5 times the number of pages. I like to use the X and the Y whenever we can, because once you kind of figure out what your X and your Y is, then if you write it like that, just a little easier. And the formulas that we have, they're all in the X and the Y notation. So I like to kind of jump in right here and start to talk about this. So what we saw was we were looking at a book on the screen, on the shared screen, that was 6.49 pages. And the model's going to predict the weight of that book. So let's look at that. So if I'm just taking this off. This is actual data, not predicted data. I don't want too much stuff on the board. So if X equals 6.49, what does the model predict Y will be? So we come on over here, and we know what we did on the screen was we took our X value and we brought it straight up to the line and then moved across. And to do that algebraically, you just take the 6.49, you put it into this equation, and do your calculation, and that's the same thing as going up and over to the right. Okay, so let's take a moment. You do the multiplication first. Okay, so multiplying 6.5 times 6.49, we get 42.185. And then adding the 1.1, we get 43.285. And I noticed that this is quite a bit different than what I had tried to get at when I was just working with the graph on the shared screen. I went back to the shared screen to check. In fact, it's difficult for me to do that straight across thing with the cursor. If we were working with paper and a ruler, I would use a ruler to go straight across and we would get better. You can see why this is actually the value on the line. It's really good whenever you have an equation to go ahead and use your equation. So this is what we call the predicted value of a book who has 6.49 hundreds of pages. And when we predict things, we put a hat on them. So it's not the actual Y, right? The actual Y is the actual weight. But the predicted value, Y hat, is this here, 43 points. And let's just go ahead and go use it to 1 decimal place. So if Y equals 6.49, Y hat is 43.3. All right, another couple of things that I want to do here is I want to look at these values, 1.1 and 6.5, and that came out of the software system. It really came out of the equations some of which are not even on your formula card. And the reason is because I never use them. Like if I ever wanted to know what this equation looked like, I would never pick up my calculator. Not in all the years I've been doing statistics. I would always put it into some kind of software system and get those parameters, get these, we call them coefficients, okay? So that's kind of what I'm teaching you guys to do. I'm not going to ask you to crunch all the numbers. There's a little bit of that in your my stat lab homework, and you should make sure that you go through StatCrunch, and I have some support for you to get those values out of StatCrunch. Okay. So what I want to do is think about what these values here mean. So we have this equation, y equals, I'll write it up here, 1.1 plus 6.5x. And a way to think about what this 6.5 means is going to be how let's take two values of X and see how the model predicts it, and then it kind of comes out pretty clearly. So I'm going to look at a book, look at two hypothetical books, right? And so we'll take a book that's 200 pages and a book that's 300 pages. All right, let's do 3 and 4. So we're in the center of the data. 300, at least closer to the center of the data, not on the edge. So we're looking at a book that's 300 pages and a book that's 400 pages. And let's go ahead and figure out what Y is for, what is Y hat, right? So what does the model predict? We're using it for prediction. We get when we put a 3 in there. So let's go ahead and use our calculators to predict the weight of a book. That is 300 pages. So we're going to look at, go ahead and try your calculators with me here. And I get Y hat is 20.6. Okay, that's what the model predicts. A book that weighs 300 pages would weigh 20.6 ounces. And let's go ahead and see what the model would predict for a book that weighs 400 pages. So let's look Y hat, 1.1 plus 6.5 times 4. Again, follow along, please, calculating with me. And we get Y hat is equal to 27.1. Okay. So notice that as my number of pages increases, the model predicts the weight of the book would increase. That's good. That is a really good property. Now, my question is how much? So what was the difference between what the model predicts a 400-page book weighs and what the model predicts a 300-page book weighs? So I'm subtracting 27.1 minus 20.6 just to see what that is. And we get 6.5. Okay. So notice that the 6.5, it is not, in fact, coincidence that the 6.5 is this value here. And I want to just get into what that means a little bit. So I'll take a little side here and remind you that in algebra, you often see these equations as mx plus b. In statistics, we'll always put and m is the slope and b is the y-intercept. In statistics, we always write it. And I'm just going to rearrange this here. We actually use a different notation than the b and the m. And we'll get into that once we get to the notes. But we always write it as the y-intercept plus the slope times x. So in this line, the 6.5 is the slope and the 1.1 is the y-intercept. And what the model shows us is that for when I increased from 3 to 4, when I increased x by 1 unit, in this case, the units are hundreds of pages, the model predicts that the weight of the book would increase by the value of that slope. Okay, and that's a standard interpretation, and we will go over that once we also get into the notes. Okay, I guess that's what I wanted to show you in this introductory video. I'm going to go back to share the screen one more time, just since we did start talking about slope. So if we look at the line here, what we did was we said that we found an estimate. We moved up, we found that if there are 300 pages, the model predicts that the weight of the book would be 20.6 ounces. That's what that looks like. And if the book is 400 pages, then the model is predicting 27.1. And that the difference between those two predictions is the value of the slope here, 6.5. Okay, so that's it for right now. I'll see you in the next video. We'll be jumping into the notes.